So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over a quick topic test with a collection of some GCSE exam style questions on trigonometry and Pythagoras at higher GCSE level. Now a copy of the questions for you to have an attempt at before watching through this video is available for you to download by clicking on the link in the description, which I strongly recommend you do to see how much understanding you have on this topic. So let's get started on this trigonometry recap and extension. Now it's worth mentioning that although most of your trigonometry will be done on your calculator, it can appear on the non-calculator paper, so it's worth just paying attention to some questions that we do that sometimes it may appear on a non-calculator question. Not to freak you out, it will only purely be testing whether your methodology and using exact values of trig. So let's get started on this test. So looking at question 1, it says, what is the value of sine A for this triangle? Now for this, it's only worth 1 mark, but I would say it's probably expected to do it in a minute. Now sine A is going to be opposite over hypotenuse. And looking at this particular triangle, we don't know what the hypotenuse is going to be. So I'm going to have to use Pythagoras to work out what BA is going to be. So using Pythagoras, Pythag, we get 4 squared plus 5 squared equals, let's just call this for say x squared. So that then becomes 16 plus 25 equals x squared. So x squared equals 41. So x equals the square root of 41. So I can just simply get rid of that x and swap that for root 41. So then going back to the formula, sine A is going to be the opposite which of this triangle, which here is the angle A. So the opposite is going to be 4, and the hypotenuse is now root 41, which is my second option. Moving on to question 2, it says work out the length of x. Now this should be a relatively straightforward basic trig question, so let's just start by working this out. So x is the size, so we start by labeling our triangle, and this is going to be the adjacent. So then pick the ratio, so this time we're going to be using cos. I've got cos theta equals adjacent over hypotenuse, and then substituting the values in, we get cos 31 equals 18 over x. So here we want to make x as subject, so I take that and we're going to get 18 over cos 31. And if I substitute this into my calculator or enter it in my calculator, I should end up with an answer of 20.999, I think it is, with a few numbers, or 21.0, and that's to 1 decimal place. Moving on to question 3, again we've got another relatively basic trig question. So here we label our sides, so we've got opposite, adjacent and theta. So this I'm going to use tan, so I get tan y equals opposite over adjacent, it should be, don't know why I've put a h there, let me just get rid of that, over adjacent, which in this case is going to be 23 over 30. So from this, to work out y, I do the inverse tan of 23 over 30, and this is what I'm going to enter on my calculator, and I should end up with an answer of 37.476 blah blah blah, or 37.5 degrees, and that's to 1 decimal place. Now when a question doesn't specify the rounding of your answer, you pretty much can write whatever you want. You can, under worst case scenario, just copy the numbers on your calculator, but I would tend to go for either 1 or 2 decimal places depending on the degree of accuracy you choose. So then moving on to question 4, it says that AB is equal to AC. So here we've got an isosceles triangle, and it says to work out the area of the triangle. Now to work out the area of a triangle, there's 2 formulas you can use. So the area of a triangle can be worked out by doing base times height divided by 2, or half base times height, or we can use a half AB sine C. Now it depends on whichever method you want to choose. So let's work with working out the height. So if I take this triangle out, this is going to be 7 and that's 25. So I need to work out what this h is. So what I'm going to do is I'm going to use Pythagoras to do just that. So to find h. So for this, what we've got is we've got 25 squared minus 7 squared equals h squared. And if I reach for my calculator, 25 squared is 625. Oh, I wrote 652. Oh, 625 minus 49 equals h squared, and that gives me h equals the square root of 576. So that's my height. So the area, therefore, then, of the whole entire triangle is going to be the base, or the height, which is 576, multiplied by 14, all divided by 2. And if I work that out, I should have an answer of, let me just work that out, and that's the square root of, that basically is 24. And so I can just write 24 there. So it's 24 times 14 divided by 2 gives me an answer of 168 centimeters squared. Now, an alternate way I could do is use this formula here, half AB sine C. Now, because this is a isosceles triangle, I can then work out what this, well, we know that the angle that we've got is going to be, well, we can work that out from using the triangle. So from this, if I just take those two sides, so I know that is 25 and that is 7. If I want to work out what this angle here is, well, that's going to be using cos. So I've got cos, let's call that x. So cos x equals 7 over 25, and inverse cos of 7 over 25 gives me an angle of 73.7. So this angle here is 73.7. So then from that, what I can then do is label this. So this is going to be my capital C, and this length here is A, this length here is B. So then using A equals 25, B equals 14, and capital C equals 73.7, I can then do a half times 25 times 14 times sine 73.7, and it should give me an answer close to 168. And both those two methods are valid. It all depends on what thought you came into your mind when you first looked at this question. Moving on to question 5. So this involves a bit of 3D Pythagoras and Pythagoras, it's going to be, I would say. So if this says work out the length of the diagonal AB of the cuboid with dimensions 5, 12 and 15. So for this, what we need to do is just do a bit of labeling, and let me just call this length X, and this line that we're trying to find is Y. So the first thing we need to do is find out what X is. So if I take that triangle out, just a poor lead written there, we've got X there, and I can work out X by using Pythagoras. So I've got 15 squared plus 12 squared equals X squared. So that's going to be 225 plus 144 equals X squared. And if I type that into my calculator, I get X equals square root of 369, and leave it in that form. And so I can rub out this X and just swap that for 369. Then looking at this next triangle, where I've got A and B, this is Y, which is what I'm trying to find. I know this length here now is root 369, and this length here is 5. So I'm using Pythagoras again. I get y squared equals 5 squared plus root 369 squared. And so y squared equals 25 plus 369. And if I add them up, so I get y equals 394 and the square root of that. So y then equals, or AB equals 19.8494 blah blah blah. Or if I round it up, 19.8, and that's in centimeters, and that's to 1 decimal place. Moving on to question 6, it says that ABC is a right angle triangle on ground level. DB is a vertical mast of height 12 meters. The angle of elevation from A to D is 42 degrees, and the angle of elevation from C to D is 35 degrees. And the question is asking to work out the length of A to C. So let's have a look at working out these two separate sides. So for this, what we need to do is we can see that this is a right angle triangle. So what I need to do is I need to work out what this length here is, and then work out what this length here is, and then use Pythagoras to work out what that green line is. So if I start by working out this pink line here, so if I take that triangle out, and we've got 12, I'm just going to call that X, and we know that this angle here is 42. So labelling this triangle, I've got O, A and theta, so I'm using tan. So I've got tan 42 equals 12 over x. So x equals 12 over tan 42. And if I type that into my calculator, I should get an answer of 13.327, blah, blah, blah. So then working with the blue triangle now, and if I just draw that out, I know that this is 12, but this angle here is 35. And this is what I'm trying to work out. Let's call that y. And so again, we're going to use tan. So I've got tan 35 equals 12 over y. So y equals 12 over tan 35. And if I enter that into my calculator, I get 17.137, blah, blah, blah. So then working with that blue line now, with the right angle triangle, I know that this length here, which is A to C, which is what I'm trying to find. So let's just call that Z. And we know that this line here is 13.327. And we know that this line here is 17.137. Don't worry if you've got those two sides muddled up. So then to find out z, we then got to use Pythagoras again. So we've got z squared equals 13.327 squared plus 17.137 squared. And we type that all into our calculator and we get that AC or z squared equals 471.321. And if we square root that number, we should get an answer of 21.7, and that's to 1 decimal place. And that's going to be in meters. So moving on to our last question, we look at trigonometry proof. It says that ABC is a right angle triangle. It says use trigonometry and Pythagoras theorem to show that sine squared A plus cos squared A equals 1. Note that sine A squared is a mathematical way of writing sine A squared. Now, if you're studying further maths or I've got ambitious of doing AS maths, this is a very, very common question. So the first thing we need to do is to work out well, we know that we're using sine A, so we're going to be using this angle here as our base. And so what we now need to do is to work out what these lengths here are. So if this angle here is A, well, to use, if we want to know sine A, well, to use sine, that's the opposite over the hypotenuse. In this case, the opposite is going to be A and the hypotenuse is going to be C. If I wanted to use cos A, well, that's going to be the adjacent over hypotenuse, and the adjacent in this case is B and the hypotenuse is C. Now, if I do a bit of rearranging for this, then what I find is that A is going to equal, if I take the C over to this side, is going to be C sine A, and B is going to equal, well, if I take the C over, C cos A. Now, if I use Pythagoras, so using Pythagoras, we've got A squared. Well, if this is what A is, then I've got C squared sine, well, let's just do that separately. So here we've got C sine A squared plus C cos A squared equals, oh, I've put plus there, let me get rid of that, equals C squared. Now, as it mentions here, we can write this as C squared sine squared A plus C squared cos squared A equals C squared. Now, from this, because we know that C has got to be a length, that C can't equal 0. So as C cannot equal 0, I can divide everything by C squared. And so what do I then therefore end up with? Well, that C squared is going to cancel with that C squared cancels with that C squared, and these two cancel each other out to equal 1. And what am I left with? Well, I'm left with sine squared A plus cos squared A equals 1, which is what they wanted me to show.